Problem. So the three questions is for this MVP, take a picture MVP we have described now is how is data provided, how is data managed, and how does data create value in the end? So first is the data source, and in this case we have an internal data source, a digital field worker, a handheld device, a tablet or a smartphone taking a picture. And since this is an internal device, we have full control of the collected system data and the associated metadata. Secondly, the picture is ingested through an API, stored and cataloged in SLIMM. Then we transform the picture into the preferred formats and the standard coordinate reference system. We then index the picture both in the local asset model and in the global coordinate reference system, making the picture discoverable both by a local and a global search. And finally, the use cases consume the data, for instance, by visualizing the picture in a 3D model of our digital twin. Another example is that we can use these pictures as part of a larger training data set for machine learning, where we detect corrosion and correlate with other sources of data that affects corrosion, like temperature, material quality, surface treatment, or nearby saltwater resources like a deluge fire protection system. As a result, we will have a generic take picture data product in SLIMM that can serve multiple use cases in different digital projects and operations. And speaking of data products, let's look at the definition of a data product and how we in the SLIMM product have used a human-centric design and design thinking approach to focus and reveal the consumption patterns of the data and how they are creating value for the end user. So a data product is a managed and reusable data set created for the purpose of creating value, basically. It has a clear ownership, a service level objective, and a known quality and a known rights to use. In our example here, the case take a picture and place it into a 3D model, for instance. The SLIMM solution managed to manage the spatial component of the picture in a way that makes it discoverable at the exact same position as it was captured, and then reused for other purposes. A picture taken for operational and planning purposes can just as well be reused for inspection purposes and vice versa. So SLIMM is an enabling project, and focusing on the consumption patterns helps us in relation to other projects we enable to clarify the exchange of information, what we would like to build, and why we are building it. For more information on data products and data mesh and how they are used in Equinor's architecture, I would like to refer to a presentation on this topic that was held at the last year's SPDM online conference by my colleagues Sun Maria Lehmann and Jørn Elmhem. I believe there is a link available for the SPDM members from that conference. Okay, so finally, let's talk a little bit about how the SLIMM solution develops through iterations together with the use cases that we enable. So SLIMM is an agile project set up as a Scrum team, and we work in 2-week sprints. To be successful, we have started small after thinking big, of course. Rather than pursuing one potentially big product in our Omnia, our enterprise data platform, we are breaking down the ideas into smaller pieces for testing, like the take a picture minimum viable problem we have used as an example today. This challenge is relevant for any sensor carrier that captures the data, regardless if it's a handheld device, a robot, or a drone. It also serves a common need across many applications, like our digital twin called Echo, apps on our digital field worker tablets and smartphones, or Equinor's digital corrosion management solution for corrosion data integration and analysis. Once we have been able to deliver a few of these data products, we have the data foundation ready for other use cases within the operation and maintenance domain to explore more advanced analytics that will support Equinor in its digital transformation. So descriptive analytics will help us with condition monitoring and condition-based maintenance, analyzing data from moving sensor carriers. Predictive analytics will support predictive maintenance, and prescriptive analytics will lead us on a path towards automation, to automated operations and maintenance, basically. To summarize, SLIMM is a data management solution that handles spatial data and media files in Equinor's enterprise data platform called Omnia. We are in open dialogue with external companies and open source initiatives to identify common problems and find common solutions in a modular design using APIs. And finally, we are starting small by working in iterations with the use cases that we enable and try to solve minimum viable problems, like the example we have used today, how to take a picture and place it into a 3D model. And now I would like to watch a video together with you, a demo video of the SLIMM solution, and how we have collaborated with the digital twin project and our internal robots and drones projects. And then I'll be happy to answer your questions afterwards. So let me just bring up the video real quick. So there's no sound on this. I'll just talk while we're watching it. So this is an internal collaboration between our test facilities and different other projects. We're starting off by looking at some inspection data into our research facility at Kårstø. Here is a flare inspection, drone inspection on the flare stack. And we have then transformed the data or converted the data from a global coordinate reference system into the local one to be able to visualize the data. And we saw that the offset of the on the vertical coordinate reference was a little bit off. So this is work in progress to adjust. And here is another data set that is collected from some robots in the local coordinate reference system of the plant. So we are able to combine these data sources in the same model. And here we have different sensor carriers, different sensors, regular camera and thermal camera that we can use in, for instance, corrosion detection. And we're not only converting the data from global to local, but we're doing it the other way as well. So some of our robots are using LiDAR and using a digital twin as a navigation map when they are programmed to do operations, and then we can convert that data set into a global coordinate reference system. So we can also use a 2D viewer to look at the different data sets, have different color coding, and use all of their attributes in the data set to sort and have functionality on top of. So this is just a dashboard to basically use the data, but we have an API for the different consumers of the data to navigate. And we also have this convenient time slider at the bottom, which makes it much faster and much easier for people concerned about maintenance or doing inspections to find their data set, because it's usually captured in the time interval set by requirements for the condition for the equipment. Here's another example for importing point clouds into the 3D model or into the digital twin. So we are using more and more point clouds, LiDAR scans, handheld scanners, scans by robots and drones. And the problem is how do you mix them, or how could they be retrieved in space and time, discovered in space and time, together with in our digital twin. So that is also something we are working on. And here we have a few examples of robots and drones that are using digital twin as a map to navigate to the nearest position of a valve and doing a valve inspection, for instance. Here you take a picture of a valve and it has a tag, and that tag is also a part of the data set that is sent to SLIMM. So we know the tag of the valve and we know the exact position, and then we can retrieve that data set, inspection data set in our digital twin and find inspection data. And this is, of course, early tests, so we haven't put much effort into making fancy icons or thumbnails yet, but that is something we can do later. And here's another creature called Animal from Anybotics. It has different sensor carriers. It has thermal imaging as well. So some of the data we saw earlier here is captured by this one. So we can have temperature overlays on surfaces that we are taking pictures of. And that's convenient when you look at corrosion rates and stuff like that. So yeah. So that concludes the demo and the presentation of SLIMM. And then I'll be happy to answer any questions you might have.
Thanks, Howard, for the interesting presentation and the demo. It looks pretty cool. Like condition-based and predictive maintenance is where we can save a lot of business value. We can increase our business value, right? There is a question from Jess. So Jess mentioned, Howard, you mentioned that about 1/3 of your legacy data has some geospatial component. Can you give an example of a data type that is not associated with a location?
That's a good question. The question is more how is that data organized? Is it organized in a way that you can use it combined with data that is well described spatially? So some of them might have a northing and the easting. That can help you in some contexts, and you might have also the vertical parameter of data. But then to really know a position location, to have the spatial component, you also need the orientation, the pitch, roll, and yaw, and what direction the data is pointing. So it could be a point of view, but it can also be a direction on the pipe, for instance. So yes, there is all data have kind of a reference, but to know the quality of how that reference to the Earth's surface is captured, in what kind of reference that is very important in the way you can utilize the data and a way you can combine that data, and that is something that we're looking at. I don't know if that was answering the questions completely, but yeah. And thanks, yes.
Yeah, there's a next question is from Kevin. Kevin mentions, thanks, Howard. The examples given we're focused on surface facilities and pictures, is SLIMM used to tackle subsurface challenges such as geospatially locating well reports, core photographs, etc.? And Jess mentions, thank you, that gives me the context.
Yeah, I just reading the question. Subsurface, no, we have a separate project, and it is quite similar in the philosophy and how we are thinking about the data science pipeline for this. So we have this OSDU project in Equinor, which is Equinor is a part of the OSDU initiative, which involves a lot of companies and consortiums. So so the OSDU project covers the subsurface domain, and so SLIMM is basically focusing on topside operation and maintenance challenges, but not only in oil and gas, also renewables, but where we are using robotics and using drone technology. So, but we are not looking subsurface, but we are looking subsea. So standardizing how ROVs collect data, utilizing the spatial component collected from sensor carriers, also on the seabed, and doing inspections and operation maintenance tasks on subsea facilities, absolutely in scope, and we're looking into that. So yeah, that's more of the focus on the domain here. Yeah.
Thanks.
Yeah.
Next. Yeah, next is Carl Jeffrey. Not sure you answered the how to position a picture taken by operator with the handheld device into a 3D model of the plant with the correct orientation. By orientation, you mean which direction the camera is pointing, not its position.
Both. So that's a challenge. So if we go to the basics of it, everyone can look at their map function on, if you have an iPhone. I guess it's the same with Android. You can look at the pictures you have in a 2D map. It will give you a fairly good positioning of that data, and it's based on the GPS signal. So it's recorded in WGS84, which is a global coordinate reference system. So you have some inaccuracy that you know of from that position, and you have the northing and the easting. So you have the two-dimensional coordinate for that data. And then you might also add the vertical parameter, so you know the heights above sea level or above the surface, or where you have your reference point. So that gives you the X, Y, and Z. But when you take a picture with an iPhone or with something else, there's a lack of how you capture the actual position of the data. So the orientation, the pitch, roll, and yaw, as it's called. So putting it more into traditional wording here, it's the direction you are looking at, 360 degrees all around. And to do that in a 3D environment, we use the 3D model to manually. So now we've done that manually. We're looking into how we can do that automatically. Used reference point you set for the picture in the 3D model to go with the data. Yeah.
Yeah, I hope that answers Carl's query. I don't see any more queries, but if anyone has query, feel free to write it down or Just unmute yourself and ask the question.
Yes, and if you don't have the question ready right now, I'll be happy to get in touch with you afterwards. Also, you can email me or make contact on LinkedIn, or I'm on LinkedIn and I'm part of the SPDM group there. So
I have one question, Howard.
sure.
I wanted to like you mentioned the possibilities in the new carbon solutions or wind technology side as well. So have Equinor looked into like via these SLIMM models of predictive maintenance or condition-based monitoring on the wind, solar like wind farms or solar farms in those arenas?
So what we do is working like step by step with a minimum viable problem approach. So what we would like to do is to start finding a standard way for how inspection data from flying drones, for instance, is captured and transferred from cloud to cloud. So the vendor cloud to our cloud with the right, let's say, the right content requirements for how the spatial component is recorded. When we have a data pipeline for flying drones, we then can use the exact same pipeline for flying drones on turbine blades on VTGs or wind turbine generators, right? So you have these turbine blade inspections to look for cracks, for instance, and other types of inspections that they do on wind turbines. So there is no difference in how you would inspect from a data perspective. It's exactly the same if you inspect a flare stack on a oil and gas installation and you inspect the wind turbines. So we're aiming to create the same data flow for the same type of sensor carrier across the industry.
Okay.
And we're into so right now I'm talked about we have an open dialogue. We have talked with Cognite, Kushal, also, and we have talked with Shell and we talked with Aker Solutions. So right now we're embarking on maybe a collaboration with some pilots with Aker Solution on flying drones inspection. We have also tight collaboration with some of the subsurface drones with SLIMM and with SLIMM, a robot, the snake robots, some other ROVs as well, or underwater automated underwater drones.
Okay.
But
that is thanks, Howard. Sorry, go on.
Yeah, I just wanted to say that what we've learned so far is that the nature of each sensor carrier can be very different, and it's a little bit different if you want to go develop let's say a JSON schema or a data schema that covers all domains. So we see that from the subsurface domains, they have a lot more cameras and a lot more sensors that are continuously recording compared to, for instance, some of the more easier cases where you have maybe a drone taking just high resolution pictures. So it depends on a little bit on the data set. But we're not done with the solution. right? So we are working in iterations, trying to look at different data sets and solving them in iterations, basically.
Yeah. Thanks. There's a question from Uber Alban. How will this solution integrate with OSDU?
Very good questions, good. I wish I'd had that answer. I just know I have very good contact with the project leader for OSDU in Equinor, and we're talking about, we see the resemblance in our architecture and what we're doing, and we're not afraid that we are gonna beat each other down, to say it like that. But as we see that there are synergies here that we can exploit going into the future. But SLIMM is now trying to release an official MVP, and maybe towards the summer. But OSDUS, they have been working, they're quite far ahead of us in a lot of areas. So data enrichment, for instance, is something that we could collaborate when it comes to OSDU, and experience also with lineage of data and how you manage data in a historical perspective. Yeah.
Thanks for that, Howard. Yeah, I don't see any more questions in the chat. So if anyone has, still feel free to ask the question, or as Howard mentioned, via LinkedIn, or I'm just posting the Society of SPDM's the Slack channel, so which you can join and have a conversation about with Howard. He's also available on the Slack channel SPDM. Generally, I mean, we try to ask some queries over there in the Slack channel in general, so that the team, the community, broader community, can also be aware of that. If not, thanks Howard for this interesting presentation, and
my pleasure.
Yeah, we will have more webinars coming soon, and yeah, stay tuned for that. Recording of this will be made available soon in the YouTube channel. So anyone wants to see that can see that later on, or want to share that. And if anyone is also interested in be a presenter in SPDM webinar, just feel free to message me or any of the board member, or just ping me on Slack on the SPDM channel. With that, thanks everyone. Thanks Howard again. It was a pretty nice presentation and conversation. Thank you.
Thanks a lot.
Bye.
Bye bye.